My name is Jose Telado, and I'm VP of HP Aruba AIOps. And I'll spend the next 15 minutes talking a little bit about what's under the hood. This is actually the appetizer because the actual main dish is Frank's. He's going to show the next generation Central. And of course, it's powered by AIOps, as was the previous Central, but just with easier workflows and more natural workflows. So going on to skipping the agenda, this is some of the philosophical thing we do. Under the hood, of course, it's data-driven, AI-powered outcomes. So the main three areas are, of course, data, models, and outcomes. So, and the maturity goes from left to right. And basically, the more earlier versions of AIOps will basically start with collecting data. The second phase is cleaning the data and dynamically at source to avoid making a data swamp. You could start with siloed data lakes where each customer's data is siloed. And then it's very hard to create outcomes that are across customers. The next level of maturity is when you actually have a global data lake. Of course, you need to be very careful about the PII, making sure you're mixing up relevant metadata, performance metrics without clients' information. And then the ultimate stage is data federation, where in addition to the AIOps team getting access to that, you actually have sandboxes for the teams in your organization to benefit from this global data lake. On the model side, the beginning of the modeling journey is just basic statistics and counting anomalies. The next level is some anomaly detected is done typically on a specific site or customer or device and trying to find some correlation. That's very early level of AIOps. It starts getting more interesting when you start using data from a customer where you go across multiple dimensions, trying to figure out if there's some structure when you go in the multidimensional space. And of course, the most of the power comes when you actually share data across all your customer base. That way you can figure out what is best of breed and figure out who's underperforming, who's overperforming, and actually recommend every best of breed configurations. Also, you could find rare needle in the haystack type interoperability issues when you have this global multidimensional data lake. And of course, after you have the models, you can't just deploy them and forget. You have to make sure you have a life cycle where you're actually refreshing them weekly, making sure the metrics are all in place, and checking that the metrics are not becoming anomalous themselves, because if the models degrade, the outcomes are not good. On the customer outcome side, if you have a very basic level of data modeling, the customers, what you're basically giving them is a bunch of alerts and events, and they have to go and use their brain as the neural network to figure out what's wrong. And as you advance, you could start putting in, you could actually have machine learning algorithms that will actually aggregate, correlate, multidimensional models that actually start root causing, recommending solutions, and ultimately self-driving. So this actually shows you where the Aruba AIOps is at. We obviously have a global data lake. I'll explain later how we actually, philosophy of modeling works. And we obviously have data federation, limited sandboxes to other teams. On the AI ML models, it's very use case dependent. Of course, for some examples, we do not control the service or application that may be failing. So the most we could figure out is this an anomaly that's a failure and point in that direction, but we cannot actually fix it. So we have all the flavors depending on the use case across anomaly detectors, local multidimensional AI models, global multidimensional models, and of course we do AI model lifecycle for all of them. On the custom outcomes, as I said earlier, depending on the use case, the outcomes may vary between just telling a user this is failing versus giving them an action of what to do next, or giving a button to say self-drive and just please run this model periodically and update the network automatically. So how do they make this possible? So this is actually the other view of data in AI models. So you can start with, you have your production cluster, you have devices connected to it, and they're sending telemetry to this production cluster. And all your models run only in that production cluster, and they use data from each customer individually. So you're not learning from each other, even though you may be in the same shared production clusters, and the jobs may be multi-tenant jobs. So these are locally trained, locally inferred. You could figure out outages, you could figure out anomalies based on the customer, seeing trends, you could do forecasting, but you cannot do best of breed configurations. You could not find rare interoperability issues because you have small data sets. So this is the first level of AI workflow, what I call local AI. Oh, actually, the top didn't change. This is the beginning of global AI. So as you can see here, the production data from each individual cluster that I showed two is PII anonymized data stream sent to this global data lake. And that includes state, stats, events, application flows for all wired and wireless devices. And of course, you send configuration and topology and model metrics, because if the models are degrading the production cluster, you need to know it and you need to flag it. So you have to, if you don't measure it, you won't know it's degrading. So this global data lake trains models that apply to all your customer base based on anonymized data. And then you could push the models. You can see the tap arrow going to all the individual clusters for all the individual customers. At the same time, you can enable APIs where you could have specific customer BI use cases. But you could go one step further. The step further is you enrich the data coming from the production clusters with complementary data. This could include things like security vulnerabilities. I'll show an example later where security vulnerabilities is very important. We obviously have access to all the engineering bugs, and we don't have bugs. We also have support cases, and then we have all the Aruba documentation. So we ingest all that. So now we could create a model that mixes up telemetry from the devices with things that we know about security, bugs, support cases. And in addition to pushing models to the production clusters that are based on all this multidimensional data, we could actually create internal use cases shown at the bottom right in yellowish. So because we're running these models globally across all our 200,000 customers and 2.5 million devices, is actually growing. And we could actually find really strange interoperability issues between specific clients and specific software versions. We could find issues in the silicon partners. We could also find new ML use cases to actually push through customers. And ultimately, when you have all this working nicely and the model's very accurate, you trust it really well, then you push it as a closed loop thing. You give the customer the option to actually select the button to just update all, and it just runs in the background. So now let's look at some use cases. So far it was just about model architecture. Now is the first use case. The first use case is around client insights, and this includes visibility, security, and policy, not in that order. Visibility first, policy second, security third. And the way we do this is you don't need additional hardware because all our HP Aruba devices actually have built-in fingerprint and behavior extractors. So we have two types of inputs for each client. The fingerprints, like MAC addresses, user agent, DCP options, and then the behaviors. What application flows, the mobility state, what is this ID type they're connected to, SNR time series. So we get an idea of like what they're doing, is there any periodicity, is there a lot of richness in the applications, of course, the username and all that stuff, all that PI has been removed. This is just behaviors on client types. And then we could run models on these inputs. And these models could use, for example, actually this one's actually, I think Frank's going to talk about it, is the IoT classifier, which is a random forest that runs on fingerprints and behaviors. It basically uses a mixture of the fingerprints, things that are fixed on a client, and things that are changing the behaviors. And then we could figure out if the device is basically operated by a human or is more of a machine headless device. So that's the first AI model we use that takes all those inputs. It obviously, it's multidimensional. It runs across all our production clusters, about 10 million unique client MAC visitors per day, and about 200 million per year. We also have Gaussian density for more detailed classification. It has about 300 labels. And then we also use language models. We had a LDA running on the previous versions, but we're actually looking at enhancing it with large language models right now. And basically, you could think about converting some of those behaviors into vectors. And then those vectors could be compared. And then you could figure out client types that are similar. And you could do two things. One is help classify devices that you already have in your labeling system, which includes about 300 categories right now. But also, you could figure out new client type behaviors that you don't have in your list of labeled data and figure out new client types. So we could automatically cluster new clients that we could start adding to our labeling system of currently 300. And I could say that we have about 99% coverage. After you throw in all these models back to back to back, we have about 99% coverage on active devices in 99%. So that's the coverage. And then the accuracy is 99% tap 3. So the reason I put active devices is because sometimes, especially if you have like outdoor APs and guest networks, you have clients that just walk by in front of your store. They connect for 30, 40 seconds. They don't actually exchange enough fingerprints or behaviors to be classified. So active devices, you have to actually do some transactions and spend a few minutes on the network for us to cover. That's why I say the 99% is on active devices. This is a very important feature. It's used for a lot of downstream AI models, where there's clustering of anomalies, finding interoperability issues, and of course, helping with root causes and recommendations. So that's on the client insight use case. Have another 5 minutes. This is on the network insights use cases. So this is a screenshot of one of the tenants. There's roughly about 40 models generating these outcomes. We use explainable AI techniques. The reason why I use explainable AI is actually for two reasons. One is we could tell the customer why we made that decision. So when we say it's 11ax is better than 11ac, these are the reasons, these are the factors that contributed to that recommendation. And also because early on, when you're starting and you actually have to evaluate the quality of the telemetry, it's good to know what features contributed to the model outcomes to go fine-tune the telemetry and enhance it. So one thing I'm going to talk about later, but we're constantly enhancing our telemetry so our AIOps gets better. So under device types, we have about 25 dedicated to APs, 8 dedicated to switches, and 6 to gateways. And CNX is going to enhance all of these. We're actually not adding new AIOps insights to the Central Classic. Everything new is going to CNX, and Frank is going to show us the CNX. And if you categorize it, by classes, there's the proactive config optimization recommendations, and there's the more reactive type. The reactive are going after changes in behavior or failure rates going up or down, where you have to say something, a service, an application, or a client group is actually suddenly misperforming. And the proactive config recommendations usually run on like a week worth of data. You don't want to be too jumpy. You want to be sure that you have the 7-day seasonality before you actually tell a user, hey, this is based on all the peers that we have in your network, this is the best for you. So a couple more use cases in the 4 minutes I have. This is something we've been doing for years, but I just want to remind people that may have forgotten, is the first thing we do before we start finding anomalies or config recommendations is clustering of our sites. Because it's not the same thing to optimize network settings for outdoor APs in Mexico City than it is to optimize APs in a Home Depot, or is it to optimize APs in hotel rooms. They're very different use cases. The propagation, the density, the AP models could be different. The client behaviors, the roaming is very different. So first thing we do is we classify all our roughly 200,000 sites currently connected to Central across 2.5 million devices into classes. So that's the output of a clustering algorithm that actually runs in 15 dimensions, but it's projected using a Tisney algorithm that actually does a 15 to 2-dimensional mapping. And the colors are the clusters we use for our baselining. So it's trained weekly. So if a customer upgrades the APs over the week, the label will likely change because one of the features of this clustering is actually the AP generation. So going through the features that are used for this clustering is there's network features around AP capability, AP density. Then there's client features. How dense are the clients? What type of clients? Are they moving with applications? Then there's environmental features, like how well does Wi-Fi propagate? Basically a SNR path loss between APs. So this is a basis that's used for things like this. So this is a clustering algorithm running for DNS queries that are failing for a specific site of a specific tenant that has been clustered relative to other peers in our database of 200,000 sites. By the way, the customer, if they don't want to do the peer comparison, they could just compare against their own sites. So if you have 100 sites, you could just compare the 100 sites against each other. If you want to know how other people are doing, you could switch the button. There's actually an oval I drew there in blue. So you could choose what the baseline is. The class baseline means other peers that are similar in that 15-dimensional space. They have similar attributes and networking, client, and behaviors. Or you could just choose to compare your sites against each other. So for this case, it's actually a weekly view, daily bars. The baseline of what's the normal DNS failure rate is shown in blue. This site for this specific customer is obviously well above the baseline. And we run a clustering algorithm, we're shown in the bottom. What are the features used in the clustering for the actual failure? So you have there's DNS failures. There's common sense there. It tells you the failure rate. And then it tells you that 98% of the DNS losses are happening on one specific server. So this is not a live thing, but you could click on that server and it tells you out of 52 servers doing DNS for this specific customer, this one server has 98% of failures. So clearly you have to go and check this server. It's the most dominant feature of this clustering algorithm. So moving on, this is a feature that just got introduced about a month ago. It's a new AI-powered firmware recommender. The reason we did this is because we were running clustering algorithms in our support database. And we found out by clustering the support cases that 10% of the support cases were related to firmware problems. Whether it was they upgraded the firmware and it was the wrong firmware, or given the topology, they mix and match devices types and they put the wrong firmware, or they're wondering what's the next firmware for them given their desires. So we built an AI-powered firmware recommender. So what are the features that you use if you're using, people actually do this for a living, whether it's SAs or whether it's TAC or QA, they actually have a sense of what firmwares work for each device, but that's just a sense. We could obviously get every AP in Central every day and see what firmware is running on them, see what the customers are doing, see the popularity metrics, see who's upgrading, who's downgrading, and see the performance metrics. So we could get data-driven running in a model on top of that and figure out what is the best firmware for each individual customer. So what was happening is people are reluctant to upgrade code. Typically, our customers are running 1 to 3 year old trains of software. They upgrade to the latest patch, but it's basically trains from 1 to 3 years ago because networking people are kind of conservative. So using the data from their peers, basically think about Netflix with, in addition, it sees if you start the movie, do you end the movie? You have a similar environment, similar viewing characteristics. Do you think you like that thing? So we use similar ideas, but it's basically the public metrics around how many APs, how many clients, and then of course, in addition to popularity metrics, we also have to use constraints. The constraints are going to be security. Of course, we're not going to recommend any software that's not secure. We need to know all the device capabilities, what firmware works and doesn't work. So right now, instead of having to call TAC to tell you what's the best firmware given the APs I have listed, this will automatically tell you what's best of breed software. Question?
Can you also do that for the clients?
No, not yet. So the clients meaning the
endpoints, yeah.
The endpoints.
I mean, you have the data.
Yes, yes. So recommend. I have a slide on us. I have, yes. I'll tell you a little bit about that. But I have a separate session tomorrow. It's going to spend 1 hour on that. So yes, so that's a very good question, Keith. So as part of the fingerprinting, we're getting the user agents. So we're getting the hardware model, we're getting the software version that's running on each client, whether it's a MacBook, it's an iPhone, it's an Android. We know exactly what version they're running, what patch. So we also know if they have interoperability problems. And actually, we have a feature that's going to be launched in the next month or two, which is an 11AX config recommender. And I could tell you that 0.5% of the clients in the wild connected to Central are not 11AX capable. If you turn on 11AX, they don't connect. 0.5%. So that's something we learned running it over 20, 30 million clients. And I could tell you quite a few customers of ours turn off 11AX capable APs because they're afraid of that 0.5. Nobody had actually quantified it, but we actually have the year they were built, the vendor, the client type, and the software version they're running. So we could tell you, you have 1,000 clients, you have these 3 that do not connect to 11AX, upgrade them. So it relates to your question, yes, we could. So this one doesn't recommend, this is Aruba device software recommender, but what you're saying is we could tell the customers, please upgrade those clients because there's issues interoperating with the APs. So that's a very good point. So let's keep going. This is actually what it looks like in Central Classic, and Frank is going to get the floor very soon. This is the old classic view. Top left is the device types. Then every row is a site. There's a recommended version, the 4th column starting from the left side. And that is actually right now AI powered. So for example, the first 2 rows, the current version was good, so no recommendation. The other sites had older code, 8.9, 8.8, 8.7, and it's recommending a flavor of 8.10, 05. Another thing this also does is a lot of our customers, they have 5, 6, 7 versions of software running on the network. So there's a lot of mix and match. This recommender tends to also minimize the number of versions each customer has running on the network. So less permutations to worry about. And I think I'll stop there because I've gone over.
And can you provide a list of those 0.5% clients that refuse to connect?
Yeah.
Better.
Yeah. Mm-hmm. So these are clients that will not connect after they see 11AX.
Oh, yeah. Just I'm looking for the list of those ones. Yeah. Cool.
So good afternoon. My name is Frank Jazz. I'm a Director of Product Management responsible for AIOps. And while Jose is the technical wizard, understands everything under the covers about how all this stuff actually is put together, we focus more on how this information gets presented to the end user and how they make use of it on a day-to-day basis. And so with that in mind, I'm going to talk about, after clicking through a few more of the slides, we're going to talk about New Central, which was introduced in a couple of sessions today already. So that therefore the embargo has been lifted on this information, and tomorrow's tech note is going to go into detail. So please don't miss that. New Central is a redesign of the central cloud management platform. And there's a bunch of different dimensions that the redesign affects. I'm going to focus on a few of them. I'm going to focus on how the AI and analytics are presented and made operational inside this new design. Also, there's a new data processing pipeline in the cloud using the latest and greatest technology for improving the latency of our analytics so that the analytics run faster and the responses come back quicker so that the results get presented to the end user. And also, mostly on the operator experience and the redesign of the user experience. You're going to see a completely different look and feel for the user for New Central. There's also a whole config change that's been made, that's been talked about. I'm not going to talk about that at all, although I can answer some questions if you're interested once we finish up with the presentation part. And so that's New Central, the overview of the different dimensions. A lot of different dimensions there. One of the other key dimensions is that we are changing our development process to follow a more continuous integration, continuous development process, doing releases on a monthly cadence. And that's much more frequently than we support today with Central. And so that will mean for the end user that features are rolling out continuously, more or less, as we improve the infrastructure. And that's what the cloud allows. It gives us the flexibility to do, with, of course, hitless upgrades. All right, so what does New Central look like? Well, this is New Central. This is actually Classic Central with a little button up at the top, which shows how to activate New Central, right up here. So if somebody wants to do an activity using the Classic Central interface, that's still going to be available. If they want to make use of the new user interfaces and the new designs, click New Central, and they end up going to this kind of display. This is the basic design of the New Central user experience, and you can tell it's 100% new user experience. The main focus that I want to talk about is that the cloud, and Jose just explained this very well, we collect a ton of data from our devices. We have 2 million plus devices connected, Aruba devices connected. We have 10 million clients per day connecting, 200 million per year connecting. We get per minute updates. There's a lot of data. One of the focuses of this design is to make that data navigable, to be able to slice and dice the data, to focus on the particular part of the network and the data relevant to the issues that the network operator is working on at that particular point in time. And one of the main design elements is what we call here on the left-hand side of the screen, the solar system, which is the navigation tool. The sun shows the context. These planets show subcontext, but notice that not only does it provide a way to navigate to see what the clients are doing, what the applications are doing, the navigation itself serves as a data display, summarizing information about that particular context. And that reduces the number of clicks and the amount of effort that an operator has to go through in order to see what they need to see. Right away, you drop in, end user sees a summary of a whole bunch of different contexts related to this particular area in this particular store, for example. And the details are shown, health of the store. We're trying to also, for every health indicator that we have, we want to be able to explain as a design goal exactly why that health indicator is showing a particular condition, whether it's poor, what are the rationale, what are the data values that contributed to that poor metric. If it's fair, if it's yellow, what are the metrics there? The goal is that if there's an indicator in the UI, that it's almost immediately, if not immediately visible, what the indicators were that caused that to trigger or with one click to be able to get to the details so that they can answer the question about what's going on here. Another design goal is for every indicator, the end user has a configuration knob to be able to tune its sensitivity and to tune whether that indicator will actually be used to contribute to health or to an alert. So they can control the levels and they can control which indicators they would like to contribute. So that for different environments, as I mentioned, there are different levels of sensitivity to different issues. Some issues in one environment are not going to be as important as others in another environment. We want to give the end user the ability to customize the sensitivity and what triggers so that they have control over how the network displays its health. All right. So clicking on the client's planet, it will highlight the client's context and provide a couple of different views. The different views are shown up here in the top right. This is the table view. There's also, I'll show a couple of examples of a graph view and other views that they can flip the display. This is a list view. It's sortable on various, every different column, and actually the columns are configurable with the widget over here on the left, being able to add and subtract columns as the end user desires. So again, the user gets complete control over what data is displayed for this particular view. Clicking on a particular client shows now the details for that client. That client becomes now the sun, the context is set, and all the planets now adjust to show the relevant data for that client. So again, with one or two clicks, they get down to the client level and see with pretty fine degree of granularity what kind of data is available for that client, what its health is, and what the various properties are. And each one of these cards that has a little arrow at the top is expandable so that they can see, for example, the connectivity blown up with much more detail about exactly how this client is connected up to the network with different statistics and other summary information. Again, the goal is to be able to, with low friction, display a lot of information. And I think our UX designers have succeeded in making something that's actually fairly dense in terms of its information content, but not overwhelming from the perspective of the usability of it. We also have, as Jose mentioned, every one of our devices, access points, switches is able to collect detailed telemetry on network activity. The access points have a full DPI engine, able to, without deploying any other hardware, be able to characterize the application flows, the layer 7 information about what's going on with the network and with a particular client, be able to look at, for example, what that client is doing, how much bandwidth it's being used. This is just a very simple, superficial example of what we can do with applications. The application capabilities and the UX that's being built here is quite powerful in the ability to be able to combine different applications together and do analytics across, just get simple, rather aggregations of data across multiple applications and be able to find out information. Again, slicing and dicing this data from different dimensions. And so that's really one of the major goals here. We have all this data. We want to be able to slice and dice down to see the segment that the operator is interested in this case, layer 7 applications. Question?
I have a question. Is there any linkage or presentation to show the difference between causality and just correlation? So you have high latency on FaceTime, but was that triggered because the network had no DHCP response? Or
Yeah,
was the FaceTime by itself?
Yeah,
They're not
exactly
linked together.
No, this shows correlation. Basically, in the alerts planet is where we try to do causation interpretations. There's a bunch of clustering algorithms that Jose's team's responsible for looking at the underlying events that were generating the alerts and figuring out what the dominant feature was, or the dominant dimension was, the dominant attribute was that contributed the most to that particular alert, which helps you hone in on what the root cause is. Am I summarizing that correctly?
Okay, yes. And I was just going to add that you're also a big fan of the AI Assist, I think that's a new name now,
Yes.
which will help.
So another dimension that was actually revealed earlier today is that there was this little, I'll go back, there's in every one of these screens, there's this indicator up at the top, which we call our time travel widget. And what that lets the end user do is look at these health indicators mapped over time. Each one of these context has health associated with it and experience indicators associated with it at the present. And that time travel widget shows how these values changed over time. So it's also possible to see a time series of that. Not only can we see the time series, it's possible to reset the whole interface back to a particular point in time. So for example, if a ticket came in that said that yesterday at 2 p.m., a particular circumstance happened, a particular client had a problem, or a particular segment of the network had a problem, or a floor had a problem, it's possible to go back to a minute granularity, click on the corresponding indicator here, and the whole user interface will reset back to that as if the operator had looked at the interface at 2:10 yesterday, and they'll be able to explore the data, look at everything as if it was yesterday at 2:10. And so this should go a long way to be able to figure out some of the issues that contributed to whatever the situation was. And it makes it a lot simpler than what currently happens typically, is where our network operators to know where to hunt through logs, to look at the historical information, and then manually piece together for themselves and cross-correlate these particular issues. Everything that we can do in the GUI will reset, so every workflow that lets someone examine and investigate an issue is fully supported back in time, going back 7 days by default.
So you say jump back up to in time up to 7 days. Is that based on system constraints, or is that informed by data that that you all have from common cases, needing to go back that far?
There was an analysis done when we designed this. We realized that 7 days is probably more than what we'll need.
Okay.
And the limit for the number of days is related to the cost of storage.
Storage costs, right? Right, that makes sense.
Be able to drop things down. And we might adjust that over time as we understand more about the costs and collect data about how often and how far back people go. If it turns out that people don't go back very far very often, then we might end up changing it, or if they go back further or would like to. So this is the first stab, is to do 7 days and to see how that runs.
Okay.
All right. All right. Client Insights. Jose mentioned Client Insights. Basically, what Client Insights does is it's focusing on the clients connected to the network, and we're trying to answer a couple of things. One is who's on the network, one of the basic issues or questions that network operators have, and also what are they doing on the network. In addition, we'd like to figure out what kinds of devices are on the network, both in terms of make, vendor, and function, but some devices behave differently than others. For example, laptops have different implications than for example, temperature sensors, video cameras, or point of sale devices. They have different behaviors and they carry different security risks. And they imply and sometimes require different kinds of network policies. For example, point of sale devices probably need to have some protected quality of service associated with them, as opposed to someone's personal tablet or laptop that has been brought into a particular retail environment, for example. And so one of the goals of this is to be able to dynamically determine what's on the network, and then be able to use ClearPass and similar policy engines to be able to automatically apply policy based on these dynamic attributes. What that enables is a network operator to specify the policy based on high-level descriptions of the desired outcome, like put all point-of-sale devices on this protected VLAN, or isolate my network cameras from my laptops and be able to describe it basically at that high level. And then the system will figure out what's meant by each category and appropriately apply the policy based on dynamic attributes. And so if we look at a different view of the client tab, and here's where we selected this other view, which is the graph view, we pick up a display which shows that same data set rather than as a list of clients, but rather as an aggregation of information about what clients are on the network, what they're doing, what kind of activity they have, top talkers, connections, and also classification over here showing what's on the network. And then clicking on that to expand it using the little icon at the top of the right of that card, we can get a much more detailed take on what's there, sorted by function, category, vendor, model OS, and then be able to slice and dice this data with more specifics as well. In New Central, unifying the alerts display, all alerts are factored in, are going to be displayed via the alerts tag. There's multiple views of alerts that we're showing the list view here. Again, these are sortable based on various criterion. The columns are again customizable so that a particular network operator can customize the view to display the information that's most relevant to them. It's also supported by time travel, be able to go back in time and see what alerts were displayed 2 days ago, 3 days ago, etc. And clicking on a specific alert, we look at the details for that alert. The planet's changed to show how many clients have been affected, other information that might be relative to the alert. And here's where we show some information about the evolution of the alert, how the alert progressed over time. And one of the things that we're adding in New Central is more correlations to group alerts together that are related to one another. There's at least a couple of dimensions that we're implementing these on as repeated alerts on the same environment that's going to be grouped together as long as the alerts are within a certain time frame that probably result part of the same issue. And our clustering algorithms will expand to include those things, and also doing correlation across topology. For example, if a switch has gone down, then all the access points that are throwing alerts because they are no longer connected will be able to get those correlated together based on topology-based correlation. So there's multiple dimensions of correlation that we can do to help figure out, to reduce the number of alerts, group them together according to underlying root cause, and start addressing some of these causation questions that we'd like to be able to answer. In addition, as Jose mentioned, we're extending our diagnostic engine, which is currently called AI Assist. That's getting expanded to be able to implement full automated diagnostic workflows, where it'll be able to probe automatically based on user extensible diagnostic scripts and be able to then collect that information and take further steps based on the information that it collected. So we're trying to address root causes here, we're trying to address correlation here, and also, again, the sensitivity of these alerts are also customizable by the end user to be able to adjust them so that in a particular environment, if a particular type of alert is not as interesting or as relevant, then they can be tuned down so that the more interesting to that particular environment, the more interesting alerts are bubbled to the top. All right, so that's most of the analytics things. Some other things that we add is a new way of visualizing the network itself. Instead of using a traditional display, which is a tree view of a network, which is a fairly decent representation of a network. However, as the size of the network increases, the tree views become less and less useful. And so instead, we have implemented a new way of visualizing a hierarchy with many levels of depth and a large breadth with a sunburst view, which enables the end user to pan and scan across the network with different layers to show health of the network or type, whether the switches access points, also the sort by VLANs, SSIDs to show the network from different perspectives. And this it's possible to zoom in and zoom out and slide this over, slide different ways. So it's like a Google Maps kind of thing. Right now it's sort of zoomed in, and clicking on a particular tab, a particular element shows, for example, clicking on the switch, then that switch becomes the center. So it's possible to also zoom in or actually focus in, drill down, rather, that was into a particular thing. Also see the details of each connectivity there. So this is a new display. I'm just going to touch on it just to show that, yeah, there's a whole other dimension of new kinds of designs that are not necessarily part of analytics, just displaying the information. Again, it underlies the fact that we have redesigned this to simplify the display of fairly complex information so that within 1 or 2 clicks, it's possible to focus in on the data and quickly grasp what with your network. So here's another view of the sunburst with a different, showing a different layer. In other words, this is the device layer as opposed to the health layer.
So, quick question. Regards looking at this, a lot of changes in the UI on this. How much of this is mostly on the UI UX side versus re-architecting of the underlying architecture of the system itself
So
to ingest a lot of these new
100% re-architecting of the UX, as you can see, and I'd say about 70-80% re-architected of an underlying pipeline.
That's a lot.
It's a lot. Yeah, the devices still connect into the same engine
Right.
for the connection, and some of the telemetry is filtered using a shared engine, but pretty soon after that, it goes into separate processing pipelines. One is the new processing pipeline. The other one is the classic processing pipeline. Right now, they're going into both pipelines.
Right. Parallel.
And the workflows and the GUI for the new is serviced by the new pipeline. The workflow for the GUI for the old is serviced by the old pipeline. Most of the analytics have been re-implemented using the same algorithms, but re-implementing them on the new pipeline, taking advantage of the new capabilities and optimizations.
Yeah, as Frank was saying, most of the algorithms got redone, and a lot of them are now in streaming mode. They used to be batch mode, so they react much faster.
Yeah.
An off-the-cuff question, right? So I see that you're looking at the network. I see you looking at the applications and devices and everything. But one of the things we're hearing is the value of the data itself, right? My data, where is it located? Is it going to be moved to the edge? Where is it most optimized? What is your view for central in terms of looking at that future where I start looking at managing my data more, the actual data itself, as opposed to the network or the applications that are using it?
You're asking about the data that's flowing on the network as opposed to the data about the network?
Yes, yes, exactly.
So you're more asking the data that's flowing on the network, having more information on that.
Yes, it's more of a strategic, longer term view.
Well,
what your view is there.
You know, I think Aruba's got one of the most compelling stories in that area in the industry because, as Jose and we've mentioned, is that the access point switches and gateways all have, the access point especially, because I don't think there's anyone else who does this, we have full DPI inspection capabilities on the access point, so we can look at arbitrary level of granularity, answering questions about what is actually flowing on the network. So we can not only look at the packet level, we can look at the layer 4 level, we can look at the layer 7 level data and be able to answer questions about what's Teams doing, what's the application performance of Teams, and then what's the volume of Teams. So we have instrumented all of our devices, access points and switches to be able to gather that telemetry. It's all being sent up, and some of the displays that you see are specifically about that. There's a whole planet, that's the application planet, that's just focused on what is that data, what are the applications flowing, how is that data being constructed, and what's happening there.
I just want to make some comment. It's the metadata about the applications, not the content of the
Yeah,
payload.
not the data, just the metadata, just aggregating
So we know
information about what's going on.
Destinations and volumes, but not the actual
Yeah,
payload.
we don't want to get in the business of keeping any of that. We just want the information about what's there.
Not the actual payload.
They talked about, you said packets at one point. Is there packet captures anywhere in here that
Oh, yeah.
would be user accessible?
Yes, yep. They just don't have those in these
Okay, great.